Good morning, everyone. Thank you for joining Megger Asia webinar. I'm Grace from Megger Hong Kong. Today, our topic is ADX, the next step in motor testing, presented by Mr. Paul Nock, who is the Renewable Energy, Rotating Machines, and Industrial Segment Manager for APAC. This is a live webinar. You're automatically muted to prevent any background noises. During the webinar, if you have any questions, please type into the question box, which you can see on the left of your screen. We'll answer your questions in the Q&A session. At the end of the webinar, please have us fill in the survey, which you can see on the right-hand side. We'll be sending the presentation materials to those completed the survey. Attendees will be able to download an attendance certificate after they have finished the webinar and completed the survey. And the recording of this webinar will be sent to you in 2 days' time by email. So without further delay, let's start now. Thank you for joining us today. Paul, I'll pass the time to you now. Thank you.
Thank you, Grace. Hello, everybody. My name's Paul Nock. As Grace mentioned, I'm the Rotating Machine Manager for APAC. This webinar today is in regard to the ADX motor test instrument manufactured and designed by Baker Instruments in Colorado. Now, Baker Instruments is an organisation that joined Megger around about 5 years ago now. Megger obviously has a very vast history of testing insulation resistance testers and lots of other products that have grown into a very large portfolio of instrumentation. So Baker Instruments was very pleased to join the Megger family. Now, what Baker Instruments have brought to Megger is test equipment that is specifically designed for testing electric motors. Now, electric motors have unique parameters, so all of the test equipment manufactured by Baker Instruments and is designed specifically to focus in on the areas where we're looking for anomalies and issues that we tend to find with electric motors. There are two types of equipment that are manufactured by Baker test equipment, and that is dynamic test equipment, where it looks at the performance of the motor as it's in operation, looking at the inefficiencies and the condition of the units. We also have a static range, which is probably what Baker are best known for. Now, the static range looks at motors when they are off of being in use, in operation. Often electric motor rewind shops are big users of the equipment, but also these days from a predictive maintenance perspective. Because these instruments are now small enough, years and years ago, when they were first designed back in the 1940s and 50s, they were so big that they could not be used portably. So it was only the big motor manufacturers that used the equipment for quality control of their production lines. But as industry has grown, as technology has grown with it, we have found that the test equipment has shrunk in size to be very manageable. And also with the latest interest from predictive maintenance and data being all important, we now have the ability to store information and trend it over a period of time, looking for opportunities where we can spot issues before they occur and we can plan maintenance around them. This would give us the opportunity not to waste money on maintenance activity that's not warranted, or even potentially be able to pick the right time when the unit does need attention prior to a failure, rather than run to fail, for example. So different maintenance strategies can lend different kinds of, should we say, cost savings to using the equipment. So a little bit about myself first. I'm a electrical, I suppose a motor technician would be the best description of my skills. I mean, over the years, I've worked for several different organizations, actually in the field with hands-on, where I've actually rewound electric motors. I've also been involved with going out into the field, condition monitoring, removing units from the field, bringing them back, repairing them, reinstalling them and commissioning them. And this was all done over around about a 20-year period of when I was working for the service industry for electric motors. So I was very lucky to gain a lot of experience working for that industry in many different segments, e.g., power stations, food and beverage, dockyards, rail, transport, as well as steel mills, cement mills, etc., etc. So I was very lucky to gain lots of different application knowledge, which enabled me to gain a lot of experience in testing in those different experiences and seeing the different issues that we tend to get from those different applications in different industries. So it was very useful background prior to joining the instrumentation side of Baker Instruments, where we were looking to close the gaps on areas where we could add value with our test procedures for certain industries and applications. So as you can see, I've had quite a lot of experience. I joined the management side of the business a few years ago, and have had the luxury of working overseas in several countries, and now living in Australia, support the region from here. So just a little bit about the ADX. Now, what is different about the ADX to our old motor test equipment and to motor test equipment in general? Well, there are some really key features. There's an added sequence test with the ADX. Now, the sequence test is it's automated, and the sequence part of it means that we can run through maybe 7 or 8 different tests without actually starting and stopping the instrument. So as we, let's say, do a resistance test, and then we run through to an insulation resistance test, maybe a high pot, a surge test, a PD test, and so on. All of these can be set up in a sequence. Now, what that means is if we hook it up to a motor that we want to test, we can run all of those tests in a sequence by just standing back and watching it, which allows the unit to be very fast through the test sequences, and also to be able to record all that information in one nice report. Now, that report gives us pretty much all of the information that we would need to make a diagnosis of whether the motor needs any attention or not. It also enables us to trend that result. So if that was a one-off test, we could then test again in 3 months' time, 6 months' time, whatever the sequence of testing of condition monitoring that you wanted to apply would be trended, and we'd be looking for obviously change, because that's what condition monitoring is. We're looking for change in the condition. So this enables us to have a whole different dynamic as per the equipment that used to be used in workshops many, many years ago. Having this extra portability of the unit, the fast testing, and the ability to be able to store all that information in nice reports, to be able to pass on to management or planning equipment for factories, to be able to schedule outages to warrant a change in the motor, or a service opportunity where we can coincide that maintenance gap to be planned in with other areas. So downtime is cut to a minimum. So and there's huge cost savings there. One of the biggest issues maintenance teams face is electric motor unexpected breakdown. And I know this all too well from my time in the service industry. I was the works manager of a couple of factories or workshops where we used to serve many different customers, and I would constantly get phone calls. We've had a motor go down. The maintenance team are struggling with it. Can you send some guys over? We need some help urgently to get the plant back up and running, because downtime is however much it is for that particular customer. I mean, we've had customers that would lose $50,000 an hour on downtime. So it's obviously critical that we have a bit of reliability, and predictive maintenance enables us to head out those potential failures before they occur. Now, we also have manual mode. Now, what manual mode means is that we can just connect the leads straight up to a motor, push the button and turn the voltage up, and we can start doing an insulation resistance test instantly. We don't have to pre-program it. Now, as you can see, the unit has got a nice digital display, and we can go in there, and if you've got an asset number or a job number for this particular motor, we can simply say 1, 2, 3, 4, and then any information that we record is saved to that serial number or that asset number. So it's really easy to manage. It can be as simple as just push the button and test, or we can set up routes, and just like vibration analysis, if you've seen one of their systems, they have a list of all the plant, and then we just go through and we can test each one in a round robin style test sequence. So there's lots of good information that can be stored and trended on the machine itself or via a cloud. Now, what we mean by cloud is with our older equipment, we used to be able to plug a USB in, save all the information to the USB, and then put it down on our PC software and store the information in software on the PC. Now it's advanced even further. Now we can, as soon as if we connect the tester itself up to a Wi-Fi signal or to our phone even, and then as soon as the test is completed, the Wi-Fi sends it to the cloud, and then all we need to do is log on our app, just like a banking app. When we look at our finances, same thing. We log on to our motor test app, and we look at all the test results that we've recorded. We don't even have to transfer any data anymore. So there's real big developments in software that has changed our equipment from being Windows operated to Android. Now, Android is becoming more and more popular. It's easier to manage rather than Windows licenses and so on. So this really is a user-friendly device now. It's a touch screen, so you can swipe left, swipe up and down, and so on, just like you can with most Android phones and iPhones, etc. So we've had some real nice advances there. Now, back in the day when years and years ago, we had our old oscilloscope, ST, D series, AWA, DX, and now we're at the ADX stage. So as you can see, we've had quite a bit of evolution, a bit of a fun slide there. We even had some T-shirts printed up with that on, which was quite nice. But yeah, the evolution of the test equipment is quite evident, as you can see. Now, the reason why these test units are bigger than, let's just say, a handheld normal insulation resistance meter or a multimeter is because of, in the back, there is capacitors. Now, some of the tests that we do perform, try to emulate is the startup process of electric motor. Now, when an electric motor starts, the contactors come in, and just prior to they make a contact, there's an arc. But they're heavily sprung, so the contactors close that gap as soon as possible. But in slow motion, there is always a gap, which leads to an arc in the contactor. Now, that arc creates a spike, which can go through to the windings. Now, if you can imagine, we're also trying to start an electric motor. So that spark, which is several hundred and maybe 1,000 volts higher than what the supply voltage is because of the arcing condition, it's also compounded by the effect of high current during the startup. So if we have a full load motor that's 100 amp full load, on startup, during that few instant while we got that high voltage spike and trying to start the inertia of the motor from standstill, we're looking at 8 times that full load current. So we've got 800 amps, and maybe on a 415 volt motor during that arcing period of the startup, it's probably going to be 2,000 or 3,000 volts. So if you imagine 2,000 or 3,000 volts times 8 times full load current, the startup condition for an electric motor is the worst the motor will ever see. It's the most stressful time. So what our testers try to do is, without the power of the joules of energy that we get from volts times amps equals power, right? So if we, during that startup period, and we've got 800 amps times 2 or 3,000 volts. That gives us very, very high wattage, lots and lots of kilowatts of power. Our tester is tiny in comparison for the power of the tester, but we do try to emulate the voltage to see if there's going to be any deterioration of the insulation between the turns and the coils, as well as to ground, but more importantly, between the turns and coils. And the reason for that is because that's the weakest insulation in the electric motor. If you've ever seen winding wire or magnet wire, you will see that there's a thin layer of insulation across there. Now that's all the insulation that we have from preventing the turns from touching each other. Now, if you can imagine the turns having that high current and voltage rushing through those turns, if electricity always wants to find its shortest path. So if there's weak insulation between some of those turns, it's going to try and jump over those turns and skip them. As soon as they skip them, that's basically a short, and those turns will heat up and start to damage the motor. So the insulation between the turns is the weakest and the one that conventional equipment won't be able to test for. That's why we need these bigger units that have the capacitors in the back to fire a pulse at low power to see if there's any weakness between those turns and coils. So that's a little explanation of why they look a little bit different to handheld testers. So this is like the screen of the units. Here we've got resistance, we've got impedance, inductance, capacitance, several results, and we've also got a surge pattern there. That's the waveform. Here we're looking at the inductance of the circuit and the voltage as it dissipates through that circuit. Now we want that to be solid. If with each pulse from the capacitor we find that there's varying strength of insulation, we'll see this fluctuate, which would indicate that we've got weak turn-to-turn insulation. It's a very quick test, very simple, but gives us the right information to look at the longevity of the motor. Now, this is critical for the predictive element. There are plenty of testers out there, and then we've got plenty of competitors that say that we can do predictive maintenance to motors. But what they mean really is, yes, we can tell if a motor has failed or if it's good. But what they can't do with a lot of the tests, such as impedance, such as resistance, such as ground insulation, that doesn't give you the window of what's going to happen in the future. Whereas the surge test, which is the sine wave test that you see at the bottom there, gives us the opportunity to look to see what's happening to the motor during startup. And if there's any weak or fluctuation in that insulation, we can continue to operate the motor, but we know it's there. And we then can start to trend the condition to see how far it can go before, or the motor can run before it gets to the point where we have to pull it out. So that's the strength of this tester. It enables us to head off any unwanted costs through downtime. There's a few things that's also new about the equipment. In the old days, we used to have leads that used to come out the front. Well, now they're actually detachable and they come out the back. Because there's high voltage in there, the leads themselves have to be protected. So there was kind of grommets that would prevent the leads from being disconnected and connected. Whereas something that's, since we've joined Megger, they've got some real expertise in this area of leads and so on. And we've able to meet the standards of protection using detachable leads. So this is a real advancement because we can then have different types of leads, different connectors, different lengths, etc., etc. So a real nice added value there. The connections in the motor itself, this is a service shop. You can see a few motors that are dismantled. We don't have to have the motor dismantled. We can have the motors assembled. There is a few things with assembled motors that we have to take into consideration, such as the rotor influence. But overall, the motors can be tested exactly the same in a workshop as they can out in the field, giving us that nice trending ability to be able to spot any problems ahead of time. Now, to prevent electric failures, you can see here are some real issues that have led to motor failures. Some are just high resistance joints. Some are, total burnouts. Some are just fusing to ground. Some are just a single phase that's burnt out, as opposed to, a total burnout, for example. And the very left small window at the bottom there, it shows like a little bit of arcing in between some turns. Now that is how these issues start, is a little bit of arcing during startup. But then over a period of time of those startups, because they carbonize because of the AC condition of the startup current being positive, negative, it kind of carbonizes. And what I'll do is that will just deteriorate very quickly. So if we're going to be testing at a certain voltage and then it starts to carbonize, then as we start increasing that voltage from 0 volts, as we increase, then the dielectric strength between the turns will deteriorate with the amount of carbonation and arcing as time goes by, enabling us to be able to predict, okay, it's starting to have unbalance across the three phases because we've noticed that the sine wave is starting to deteriorate at maybe 1600 volts. So we'll monitor it. It might be 1400 volts next time, then it might drop down to 900. But as soon as it gets to the supply voltage at, say, 400 volts, then we know that we've got a potential dead short, and that's when it starts to burn out. So this is where our window of opportunity kicks in, and we can start to plan our predictive maintenance. The reports, like I say, they're instantly created on the instrument, and it's cloud-based, so it's pass-fail. We've got pass, we've got fail. Inside the instrument, there's templates. So let's just say we've got a 460 volt machine, like in this example. Then we have a percentage of, say, 3% unbalance, which is acceptable. And then at the side here, where it says imbalance, across those results to the left, the resistance, the temperature corrected resistance and inductance and so on, impedance, sorry. And then what we've got down the bottom there is our levels of unbalance, which are pass. Then we've got our insulation resistance, our high pot, our polarization index, our step voltage test or our high pot test, and then we've got our surge. And if we did a PD test, we could add that value. So that gives us a summary of the test equipment that we now have in the ADX, which is our latest instrument to be released recently. Grace, if you're there, what I'd like Grace to do now is to play a video that would show the release that we had at a motor organization called ESA, Electrical Apparatus Association. So what that means is that this organization is particularly well supported by the electric motor service and manufacturers, and they have various recommendations of tests and standards that they apply, which we meet and are supported by. And it's a big conference, usually in the US once a year. And the video is going to show an introduction from the product line manager for Megger, Richard Wardak, who's going to present the ADX to that organization. Now, like I said, it happens every year. This particular one was set last June, in St. Louis in the US. So this little video will just show his introduction to the ADX and what's new, but visually, so that you can see the accessories and things like that. Okay, Grace, if you could play it, please.
Yes, the video will be played now.
Okay.
Good afternoon, and thank you for joining us today at ESA in St. Louis in the new Solutions Theatre. My name is Richard Wardak, and I am Motor Product Manager for Megger Baker Instruments. And it's with great pleasure and pride that I introduce to you our new automated static motor analyzer, the ADX. Now, this represents the coming together of our existing manual and automatic products, the DX and AWA. These products have been the two most successful surge testers ever to be produced in Baker's 61 years of manufacturing in Fort Collins and have secured our position as market leader. The ADX will be born from customer and sales feedback with many focus groups. And during the project, we've gained valuable insight from our alpha and beta partners. In fact, some of you in this room today will recognize those particular features which you have suggested we improve. So thanks for your help and thanks for your support. So let's get to it. Here's the ADX with some of the accessories that are available. We're launching the standard model today, with the armature and power pack versions following in a few weeks. The base models by voltage are 4, 6, 12 and 15 kV. The 15A model will have the armature coil built in, so there's no need to have a separate coil test accessory. There are several variants available whose features can be customized according to whatever you need, so just let us know when you're ordering. So just before I scroll through the test screens, let's have a look at the main features of the ADX. I'd like to categorize these as safety, security and usability. Now, something that was repeated time and time again during our feedback sessions was the irritation with the test leads, namely being permanently connected. When these become damaged, the unit has to be sent back to the factory for repair. Now, losing your tester for a month now is just unacceptable, especially running the risk of damage in transit or delays through customs. Now, we saw this as an opportunity to develop high quality, single, detachable, combined high and low voltage Kelvin test leads. So if you need a replacement, you can just order one single lead. But if you need longer or shorter than the standard length, we can help you out. And for those who know of IEC 61010, you'll be familiar with the high standards for safety which have been set. We have met these and surpassed them. The security of your data is of the utmost importance to us. But you told us that you wanted to be able to access your data on any internet connected device like a PC or a tablet or even a mobile phone. Our solution has been to create a secure database for each customer with access through bespoke cloud-based software developed by our partners PowerDB and College Station, and they will take you through a quick tour after this presentation. But we also understand that some of you cannot, will not, or are prohibited from connecting to the internet to access your data. So for you, PowerDB has created Print Engine. Now, this is an offline program for your PC that can take the test data from the ADX and create editable reports. And by the way, PowerDB Dashboard and Print Engine are free. Usability comes in the form of a 10.4-inch daylight viewable touchscreen display with clear icons and easy navigation. We also have a waterproof industrial keyboard with mousepad. And we're also able to import existing databases from our existing test equipment, the DX and AWA. So these are just a few points for now, and as you can see, there are many more. But one more thing before I move on is the battery. No, sorry, you can't test with the battery. Well, not yet. There is no rebooting of the ADX if there is a power outage or when it's unplugged. So you can move between motors and the ADX will keep your settings for several hours until you restore the power. Time's catching up on us, so let's have a quick look at the ADX. On startup, you're able to check the software and firmware is up to date and download updates and install them as necessary. As we log in, you can see that as an admin account holder, you can create user IDs and roles for your team. Logging into the ADX with the code will then come to the splash screen, which is the return screen that you'll always come to in ADX. In here that we've got manual testing, automatic testing, sequence testing, and most importantly, setup screen. Within the setup screen, we can set tester configs, which will set the parameters, the values on whether a test is actually performed or not, and save that under a specific name. You can copy, you can change them, you can edit them. And we can also create and edit assets. And within the asset, you've got all the nameplate information that you need. We can assign a test configuration, and we can also assign attributes if we need to. So a good point to note is that there is two-way synchronization between PowerDB dashboard and ADX. So whatever alterations are made on dashboard will appear in ADX. One thing I forgot to mention, we've also got reports. We can view reports on the screen, or we can print these reports wirelessly or to a connected USB printer. So let's take a quick look at the accessories. Now, before me you can see there's a selection of what can be used with the ADX. Now, we created an adapter that we're able to take advantage of the MTR105 small Kelvin leads, the clips and the probes. But we can also use the DLR010 Connect system with the larger clips and probes, for example the concentric probe and the duplex probe. And we also have the warning lights. Now, as far as we're concerned, that these will be included in every ADX. Safety is not an optional extra. Now, we were talking about MTR105, so I'd just like to take this opportunity to let you know that the 105 has had serious software updates to give percentage difference and temperature compensation. So check this out when you go to the stand, because I think you'll be quite pleased with what you see. Thanks a lot.
All right, I guess this is the end of the webinar now. If you have any questions, please type into the description box. Paul will answer your questions. And for those of you who are leaving, please remember to help us fill in the survey, which you can see on the right of the screen, right-hand side of the screen. And we'll be sending the presentation material to those without the survey. And you have already completed the survey, you can download an attendance certificate, which is at the bottom control panel, the icon on the right-hand side. We will spend a couple of minutes to answer your questions in the question box. All right, we got some questions here. Paul, are you ready to answer the questions?
Yes,
Okay.
far away.
All right. The first one we have is what voltage level of motors this test equipment can be applied to?
Okay, so electric motors come in obviously various sizes, various voltage levels. The equipment that we manufacture goes right the way up to 40,000 volts. Now, some of it starts at as low as 2,000 volts and 4,000 volts and 6 and 12 and 15 and then gradually up to 40. Now, this covers almost all of the electric motors out in the field and of any description, whether they're DC, slip ring motors, synchronous, whatever. But obviously, the bigger the motors, the more power that we need to test the bigger motors. So, and the higher the voltage. So you would select the test equipment that would suit the plant that you've got. So most people on a fairly big plant would have up to 6.6 kV. Occasionally, you get really big plants that go up higher, of which we can meet, such as power stations, etc. But averagely, we find that most, the average, let's say, paper mill or maybe steel mill would probably have 6.6 kV motors. So our 15 kV tester will meet all of the recommended levels that we test 6.6 kV motors to. And then if we only have customers that only have 440 volt motors on site, then they would only need probably a 4 kV tester to cover all those motors. So the answer is to that question, yes, there are many different types of motors, but the test equipment is capable of testing all motors that we have in the field.
All right, thanks, Paul. And the next question is, Aaron would like to know more about ADX electrical tests.
Okay, so the tests include ground insulation. They cover basically various tests needed to test the two insulation types in an electric motor. Now we have one of the insulation types is very common. All electrical circuits have ground insulation. So the insulation resistance measurements, including the variants of that, such as polarization index, dielectric absorption, step voltage, HIPOC, these types of tests, we cover all of those because they all have like different elements, but pretty much they're all the same test. We're just applying a voltage and measuring the leakage to ground. So that's covered, that insulation type with those type of tests. But then the other insulation type that we have with electric motors and generators and even transformers is the winding insulation between the turns and the coils. And there is no better test and repeatable test from a condition monitoring perspective than we get with the surge test. I mean, if you think about resistance gives us a balance, a pass or fail. But if we have an unbalanced resistance, let's just say because the windings are shorted, then what that would mean is that we have a motor that's already failed. It's already shorted between the turns. Or if we've got a high resistance joint, then again, it's already got unbalanced current going through it. It's already got heat going through that high resistance joint from a crimp or something like that, which is determined again, very easily with the surge test. But we wouldn't know it's occurring until, if we weren't applying the surge test, until after the damage was done, pretty much with the resistance meter. So, the surge test is the most commonly one used. Now, there is a new test that we have, which is partial discharge on our surge waveform. Now, there are many different types of partial discharge. And the one that we apply is as the capacitance fires the pulse through the winding, we're looking for any discharges. And we measure these against millivolts. And then we have like an inception voltage of any discharges, then a repetitive discharge as we increase the voltage up. And then what we do is once we have that repetitive discharge, we then decrease it looking for the extinction of that discharge. And we plot it. So once again, it's not really a pass-fail criteria. It's more of a trending tool that as the motor becomes more and more contaminated with carbon or moisture, then that partial discharge should change and deteriorate. And our inception voltage of any discharges would come down lower and lower. And just like all condition monitoring, we're looking for a change. So it's a nice added tool to be able to indicate whether we've got deteriorating insulation on our turns through partial discharge. What I would say is that we have found that when we do the surge test, we can actually pick up deterioration in the turns prior to partial discharges through deterioration and insulation breakdown. So to us, the surge test is still by far the best test available to be done easily and quickly through as a predictive maintenance test.
All right. And the next question is, can the ADX be used on reluctance motors?
Any motor that has winding wire or magnet wire, where we're looking for that deterioration to ground, and we're looking for deterioration between the turns and coils, the equipment is suitable for.
This one is it able to perform tangent delta measurement?
A tan delta measurement is, I mean, Megger manufactures equipment that does tan delta testing, and we don't have it built into this particular test equipment. It's there is a limit to what we can put inside a box, and so there are certain tests that need other components that would make the test equipment unpractical. So if you see value in tan delta, I mean, I've been involved with tan delta. It's a trending tool used for usually high voltage motors, where we look for like a change in the angle, which could indicate that we've got carbonized air pockets in the insulation. So once again, it's looking for the types of problem that we would find with surge and partial discharge, slightly different. But the problem, by the problem I mean, you know, the deteriorating insulation of the windings. So once again, the reason why we selected the test equipment, the tests to be put inside of the equipment that we manufacture, is the practicality. The test equipment that we have is simple clips. So we just clip it onto the connections and we run the test. In some test equipment, it can be a little bit more complex than that. Partial discharge, sometimes with the online PD, we have to put extra coils in circuit and things like that. And partial discharge usually, tan delta usually has extra equipment that's needed for transport and so on. Whereas the equipment that we kind of manufacture at Baker is really designed for practical tests out in the field. Don't really want to get involved which ones are the best, but we've found at Baker Instruments with research and feedback from customers that you know, the tests that we keep in our testers are the most relevant and easily repeated on a regular basis to be practical for maintenance teams.
All right. And next question is, which model of ADX is appropriate for 11 kV motors, and what is the price range?
Okay, so price you would have to speak to the commercial team. I'm not really here to talk about pricing right now, but it's in line with our previous equipment. It's very easy to get any pricing information. There's Megger has many people that in every country that you could approach, and also on the website. Please send me an email direct, or Grace an email, and we'll connect you up with somebody that can give you a price. Now, which model? There are various different models of the ADX. You know, you can pay for as much or as little as you want. If you're not interested in partial discharge, for example, you don't have to pay for it. We reduce the price. So once again, pricing is difficult unless you look into the capabilities and you decide which tests you want to be able to use. It's a bit like a car. If you want certain add-ons, you have to pay extra for those. The test equipment for, say, 11 kV motor, we would probably recommend for that kind of motor according to the standards. Now, without recommending a particular standard, let's just say IEC 522 is a standard, or a recommendation, should I say, from a standard committee, and that would be probably around the I don't know, the 24,000 volt range. Now, we need to have a tester that's going to cover that. And what we would need to do for that big of a motor is have what we call our power pack. Now, the tester itself sits on top of a power pack, which boosts the voltage from the tester itself, which is a maximum of 15 kV, to 40 kV. And then we will be able to test up to 40,000 volts. But the standard for to be honest, the Baker standard that is applied mostly globally, certainly by the service industry, is twice the working voltage plus 1,000. So if it's 11 kV, 11 kV times 2 is 22 kV plus 1,000. So we would be testing at 23,000 volts for 11 kV. That's what our recommendation from Baker Instruments is. And as you can see, if you had a 30 kV tester, then that would cover that range of motor very easily. And the ADX that you saw in the pictures, maximum voltage range is 15 kV, but it does come in 4, 6, and 12 versions as well, by the way.
Okay, and the next question is armature testing available now on ADX?
The armature testing will be available soon. We're actually showcasing it at the next Easter event in next month, I think. No, in June. This time it's in Washington, D.C. So we have a show, a new instrument theater that they have at that particular conference, where the armature and power pack function will be showcased. But as far as adding it to the manufacturing at the moment, it's not available. But as you can see, as being as we're going to be showcasing it, it will be available very soon.
Okay, and the next one is a good summary of the ADX, being it combines the manual features of the DX with the automation of the AWA.
Absolutely, yes. We have two existing instruments. We have what we call a DX, which is a manual instrument, and we have the AWA, which is an automated instrument. So the ADX is combining the capabilities of those two instruments into one unit, the ADX. So the answer is simply yes. We have the capability of the AWA, and if you know our DX instrument, then we also have the capability of the DX, plus added capabilities of cloud and easier transfer of data.
All right, and the next question is ADA for high voltage motor only, or you also have models for low voltage?
Yes, absolutely. The low voltage are the most common motors globally. In fact, the majority of our business is in that range. If you can think about these days, a large 440 volt motor could be 400 kilowatt. I was at a factory in New Zealand just a couple of weeks ago, and we were testing the motors in their stores, and they had a 460 kilowatt motor there that was 440 volt. That was 440 volt. That's the biggest one I've seen of 440, but it was basically as big as as a table, as a small sofa. So it's a very large, powerful motor, and we would use our 4 kV tester for that. So that's very, very easy, very low priced test option for a very large motor. There are different, I don't really want to go into the characteristics of electric motors, but the different characteristics indicate different current levels during startup and different designs. The issue with having such a big low voltage motor is the startup pulling so much power from the supply, which could cause issues from the power company, as well as other issues as well. But overall, quick answer is that no problems. 440 volt is very commonly used, and most of our customers buy the smaller range ADX and DX and AWA to test that range of motor.
All right. The next question is, could partial discharge be used in low voltage motor?
Yes. Manufacturing uses it. For example, we've got some customers that manufacture very small motors, and they use partial discharge as a way of discovering if they've, I don't know, they've kinked the wire or they've stretched it somehow during the manufacturing opportunity. What I would say is that it's not something that is a common test for that range of motor. The answer is yes, you can do it. Personally, I probably wouldn't look to do it in day-to-day maintenance. If I was suspected that the motor was, let's say it was tripping or there was an issue with it, and I wanted to investigate, then I might do all the tests I could on it to find out more and more information to make a smart decision. But in general, for that range of motor, I would say the average technicians would not use partial discharge for those motors, but it is possible.
Okay, I think it's the second last question. Would you mind giving a rule of thumb of the acceptable motor intrusion resistance value? Our clients here usually don't accept a test result below 100 milliohms or for any motors.
Okay, I think it's megohms is what you mean, Grace. So the standard acceptability for most of circuits these days is 1 megohm. I think that's the common rule of thumb. Now, 1 megohm is really low. I personally, if I was running tests on a motor, I would want the tester to be able to flag anything under 100 megohms, maybe even higher. It depends on the environment. I've had a customer at Steelworks that has very low insulation resistance across all of their electrical circuits, that their standards are even lower than very low. Let's just leave it like that. But what I would say is that my recommendation is that person is quite right. I would set my alarm levels generally higher than what the standard suggests, simply so that I've got a level that would show an alarm that then I can react to prior it to reaching the safety zone where we're not allowed to switch the circuit on. Because anything less than the 1 megohm level means the circuit's not safe to switch on. Whereas if it was 95, it would have been flagged on our tester, but at the same time, we can continue to operate it while we're investigating what's causing the low megohm level.
All right, and here comes the last question. How could ADX help in checking the health level of DC armature?
Same thing as any winding. Now, there's a lot of people just use resistance, doing bar-to-bar testing across an armature, and maybe short all the bars out with some fuse wire, and then test it to ground. But really, that's not a very good test or complete test. It's certainly adequate to show if there's an issue or not. But once again, the good thing about using a surge test, and a lot of traction organisations with DC motors on trains, they must have reliability when those motors go back into service on the train. If a train suddenly breaks down due to motor failures and so on, or motors fail, then they have to call that train in from service, and it's at really high cost. So a lot of the companies that we deal with have a standard test where they would surge test bar to bar in between the turns and the coils, looking for weakness ahead of time, looking for insulation degradation between those turns and coils, that what we would normally find with just a resistance check wouldn't show up. So, having done this test on hundreds of armatures myself, I've often found that just going around with a ductor or a low resistance ohm meter between the bars would give me a balanced result. But then when I went round with a surge test across the bars, I would sometimes find issues that the resistance wouldn't show. So therefore, it's to me that showed that particular test would give us a lot better reliability than just the same resistance tests.
All right, thank you, Paul. I guess we don't have any more questions now. If you have any more questions, please send us email to megahongkong@megger.com. You can also go to our website, megger.com/webinars for our future webinars. And just a reminder, please complete the survey and download the certificates before you close the webinar window. And the recording of this webinar will be available in 2 days' time by email. Thank you, Paul, again for a wonderful presentation. Thank you all for attending. We hope to see you next time. Thank you. Bye-bye.
Bye-bye.